Hello, class, and welcome to the next lesson. For this lesson, again, I'm doing a video of my computer screen, and there's two things that I want us to get from this. I want us to see how a wave reflects off a rigid boundary, and then I also want to see how a wave reflects at a loose boundary. And I have a nifty simulation here that I can use to demonstrate these things. I have a link of the simulation in your handout for the assignment today, and also in the description of this video on YouTube. So this is the default screen. What I'm going to do is I'm going to set it to a pulse mode because a singular pulse can still, it'll show us how the entire wave would, we can see one instance of the wave front interacting with the boundary. Up here in this right hand corner, fixed end, loose end, or no end, I want to see the fixed end real quick, okay? So pulse fixed end. Just for argument's sake, I want to have almost no damping, but I'm going to keep a little bit. I'm going to keep a little bit, and let me have a pulse width. I'll keep it like that. I want to make the amplitude high. So I just want us to see an instance of the pulse. Okay, you see, so this is our, I'm going to increase damping slightly actually. This is our, um, our wave, and this is our fixed end. I'm going to go to slow motion. By introducing some damping, its amplitude decreases over time, which means it can lose some energy here at the boundary. Maybe some of it's transferred. A lot of it is reflected. Now, for a fixed boundary, I'm going to put this in slow motion and hit play here, or I'm going to hit the pulse. So as it travels, it's almost at the boundary here. What do you think is going to happen as it's reflected? Sure, you've read it in your textbook maybe, but um, maybe we can think about it. If here is a rigid boundary and most of it's reflected, it could either be reflected by keeping its positive amplitude, or it becomes inverted and out of phase. So for a rigid boundary, let's see what happens. Oh, it became inverted. You know, for rigid boundaries, that could be maybe a wave even passed from a lighter string into a heavier string. The heavier string has um, it's more massive. So a force that creates a pulse in a lighter string won't bring it up as highly in a heavier string. So from from a lighter medium into a more dense medium, that could be thought of as a rigid boundary. Okay, now let's look at the loose end. So, and to simulate this, we have a pole here and a ring around the pole. It's free to move around. Watch what happens when I send a pulse through the rope in this instance. I'm going to hit pause. Remember, this is free to move. What will a reflected wave look like? Question mark. Well, let's see. Oh, wow, check that out. It was free to move, so that its amplitude stayed in this positive direction. And actually, this is really interesting on this side. Again, this can be thought of as a boundary also. So it's inverted when it comes back. Here, let's see that again. Loose boundary, it keeps its amplitude. Rigid boundary, inverted. Okay, so I hope this helps to answer some of your questions. The other things to remember is the wave speed depends on the medium itself. Um, and for a wave being transmitted between boundaries, it's going to keep its source frequency. Okay, go ahead. Good luck on the questions. Until next time.